I got good news, and bad news.
Worst to best.
Worst to best.
Yeah.
Bad news first. I don't have your test corrected. Haven't even looked at them yet. News. We start a new unit today. Good news. No graphing today.
Nice.
Yeah? So, Unit 3 is what we're going to start today. And really, it's the reason that I go with units instead of chapters, because there's some out of chapter 4 and there's most of it's out of chapter 5. So, but we're going to go with units this year and topics, and so we're going to start topic 3.1 today. And that's going to be all about exponents in scientific notation. Yay! So, good stuff. Huh? All right. So, given the fact that x to the fourth is equal to x times x times x times x, what I would like you to do is, I'm going to give you a couple of minutes here to answer those 6 questions. Okay? See what you come up with as an answer for those 6 questions. I get it. Noise. It's just a liquid going through a pipe. It's annoying sometimes. Answers for number 1. I'm not going to tell you what's right. I'm not going to tell you what's wrong. I just want to know what you got. x to the 7th. Anybody get anything else? Other variations? We got
X to the 12.
x to the 12th. Any other variations? Okay. Number 2, answers.
2x to the 6th.
2x to the 6th. Other ones?
8x to the 6th.
8x to the 6th. Other ones? Number 3. Other ones? Four.
X to the 6th over 9 y cubed or 2. Whatever.
You tell me.
9 y squared.
Other ones?
X to the 8th over 9y squared.
Other ones? Somebody that hasn't given an answer yet. Number 5.
X to the 12th.
Other ones? Somebody that hasn't answered yet. Give me one for 6.
X over x to the 5th.
X over x to the 5th? Other ones?
1 over x to the 5th.
Other ones? Anybody have an answer on their paper that didn't make it up onto the board? Right, wrong, or indifferent? Just something different than what's up there.
Reply by x to the 7th. For 6, I had x to the 1/5.
X to the 1/5 power? Like that? Any other answers that didn't make it onto the board? Okay, so this one is x to the 7th. This one is 8x to the 6th. This one, I only got one choice. Luckily, it's the right one. This one is x to the 8th over 9y squared. This one is x to the 12th. This one is that. Okay? So let's refresh our memories on the actual properties of exponents. Okay? Now tonight in your homework, you're going to be asked to talk about all these different properties, and there's names for all these properties. Okay? But I don't really care about the names. I more care about that you know how to use these properties. Okay? First one is when you are multiplying with the same base. So you're multiplying two terms that have the same base. Okay? In that particular case, the base stays the same, but you add the exponents. Okay? So for multiplying with the same base, we add exponents. If we're dividing with the same base, here in number 3, again, the base would stay the same, but now you subtract the exponents. when you have a power to a power, like in number 2, a to the m power and then to the n power, that's when we multiply the exponents. Negative exponents, what we do is we don't like negative exponents for one. So to make them positive, we take the entire term and we move it to the opposite side. So if it's on top, so if there's a negative exponent on top, we move it to the bottom of the fraction and it becomes positive. Likewise, if I have 1 over a to the negative m power, I can move that negative exponent to the top and it becomes positive. Okay? So you move it top to bottom as to how you want to to adjust it. And positive there is best. 2 more for you. Number 5, anything to the 0 power is equal to 1. Okay? Anything to the 0 power is always 1. And lastly, when you've got a crazy combination of a lot of different things, this exponent here is controlling this term and it is controlling this term, but it is not controlling the a. So therefore this exponent would have to go into there and into there, using the power to a power rule that was, I think it was number 2. So then this would become a times b to the mr power. That's an r. That's a bad r. We'll start over again. C to the nr power. Okay. Got to know what your exponent is controlling. Okay. So with that being said, let's try these now. Okay. Give you a couple of seconds here to try these two. Kind of like the distributive property, but in the exponents term. So 2 cubed x to the 3 times 3 power and y to the 2 times 3 power. So when that's all said and done, that's going to be 2 cubed is 2 times 2 times 2, which is 8. If it's a number with an exponent on it, we can do that math. We're not going to be scared of that math. If it's a variable, then we would just simplify it. Okay, so then that would be x to the 9th, y to the 6th. In number 2, first off, we got a negative exponent on the top. So I take that and I move that to the bottom to make it become positive x cubed. We also have a negative exponent on the bottom, so I move that to the top and have it become positive. Now that we've got the same base with exponents, we subtract those exponents. So then this is going to be x to the 4th. Try those 4. Mm-hmm. So the numbers here in number 3 can get multiplied together because that's what we're doing there. And then the exponents on the x get added together. The exponents on the y get added together. So then this becomes negative 6 to the, or times x to the 5th, y to the negative 6th power. But we don't like that because we've got a negative exponent. So that becomes negative 6x to the 5th all over y to the 6th power. So this becomes 4 to the negative 3rd power, m to the positive 6th power, n to the negative 12th power, when I multiply these powers. And it's power to a power. So then this would become m to the 6th over 4 cubed n to the 12th. And then from there we can do some more math. M to the 6th power. 4 cubed is 4 times 4, which is 16, times 4, which is 64. N to the 12th power. Number 5. So we've got 8 d cubed all over 12 c, but then this c comes down to the bottom, so then that's c squared, and then you got d to the 4th. Well, now we've got all positive exponents. Okay? 8 over 12, I take that, and I simplify that fraction. Both can be divided by 4. So then that gives me 2 over 3. C times c squared becomes c cubed. D to the 3rd divided by d to the 4th leaves me with 1d on the bottom. This becomes negative 3 cubed x to the 12th over y to the 9th. Negative 3, and I should put parentheses around that because it's that whole negative 3. Negative 3 cubed is negative 27. And then we got still x to the 12th over y to the 9th. Scientific notation now. Combination of, you've probably seen it sometime in one of your science classes. Okay. Scientific notation is a way, a method, if you will, to write, oops, that's a bad Y. Large or very small numbers. There's a couple of rules that go along with scientific notation. The first rule is that you can only have one digit in front of the decimal point. Adding and subtracting scientific notation numbers can only happen if the exponent is the same. Okay? We're going to focus primarily on multiplying and dividing. So the procedure that we're going to use is we are going to multiply or divide, actually I can use the divide sign there, or divide the number and then add or subtract the exponent. Okay? And we can have negative exponents in scientific notation. Okay? Put that as another rule too. Okay. So on this particular one, here on number 7, I'm going to multiply those two numbers together. Then I'm going to add, because I'm multiplying, and the rule with multiplying at the same base is you add the exponents. Because I'm multiplying, I'm going to add those exponents. .8 times 3.6 is, I believe it's 24.48. Yes? No? Maybe? Yeah? Okay. Times 10 to the 10th power. But the rule says that this number here can only have one digit in front of the decimal point. So that's going to change over into be 2.448. Because I moved this decimal point to the left 1, I'm going to add 1 to my exponent. If I move that decimal to the right, I subtract 1 from my exponent. Here in a divide problem, I take my numbers and I divide them. I take my exponents and I subtract them because it's a division. 9.3 divided by 3.1 is 3. (16 minus 4 is 12. Another part of exponent rules comes utilizing formulas. So sometimes you'll be given a formula and you'll ask to write an expression using that formula. So in this case, we have the volume of a cylinder. The volume of a cylinder is pi times the radius squared times the height. Excuse me. So, looking at my picture, this is my radius, this is my height. Or sometimes it might tell you right in the problem which one is which. Okay. So I can substitute that in. So the volume here is equal to pi times my radius squared. Well, my radius is 2x. Color code it here. And then that's going to be multiplied by my height, which is x over 3. 2x quantity squared is 4x squared. Fractionize everything. When we're multiplying fractions, we multiply across. So we multiply pi times 4 times x squared times x. That gets me x cubed. 1 times 1 times 3 is 3. So the expression for the volume of that cylinder is 4 pi x cubed divided by 3. This homework will be due on Monday. There are some problems that say, tell which property of exponents you used. You don't have to do that part. I'm not going to be looking at which property of exponents you used. I'm looking more for the final answer of what you did than what property you used to get there. Okay? No, yes. Whoops, tap the brakes. Not that. Yes, should be topic 3.1.